Okay, so 2.2 is on what we call unit circle trig. So it's our second week of trig. And the goal in this section is basically to figure out a coordinate, and then we're going to use that coordinate to do something. Okay.
Like a coordinate on a circle?
Yep.
Oh, that's pretty
So
spiffy.
let's start with that diagram. Okay, that is the diagram of a unit circle. Okay, unit means that the radius of the circle is 1. Okay. We did talk, I don't know what you're referring to. We did talk about a unit circle last week with something, but we didn't get into what we're doing now. But yes, we did bring this up last week. Okay, so what I've done on the circle is I've marked 4 different locations: 0, 90, 180, and 270. We're going to start by looking at those coordinates because those are the easiest ones to do. So in general, let's just say we had a coordinate or an angle anywhere on this circle. It doesn't matter how big I draw the angle. We're going to make sure the initial side is right there, and then terminal side can put wherever we want. The point is, when you draw an angle, no matter how big or small you make it, the terminal side is going to hit the edge of the circle somewhere. And the goal in unit circle trig is to figure out where that side of the angle comes into contact with the circle. That's the coordinate we need to figure out. And then once we have that coordinate, we do something with it. To figure out that coordinate, you have to find 2 numbers: the x value and the y value. Any question on that idea?
So there's like no grid?
You won't need a grid, no. Yeah, you won't need a grid. Yeah. All right.
And so like we have it in like 4 sections, are those like, would those be like the quadrants?
Yep, so the angle, it could be, if the angle was bigger, then the terminal side could come up and go into a different quadrant. Yep.
Okay.
So we're going to, today and tomorrow, we're going to focus on the angle being between 0 and 90. That means the coordinate is always going to be somewhere in this section.
Mm-hmm.
So that means it will have a positive x value and a positive y. Yep. All right. So first thing to understand is what can you use unit circle trig for? You can use unit circle trig to work with angles that are multiples of 30 and 45. That's what unit circle trig is used for. So it is not used for every angle. Okay. Unit circle trig is designed to work with angles that are multiples of 30 and 45. So what do I mean multiples of 30? 30, 60, 90, 120, so on. And then multiples of 45, 45, 90, 135, 180, 225. And there's some overlap, like 90 is a multiple of 30 and 45. It's a multiple of both. Okay. But any angle that is a multiple of 30 or 45 can be represented as a coordinate on the circle. When we rotate on the circle, there's 2 different directions. Does anybody know how we describe the 2 ways that you can rotate on a circle? Counterclockwise and clockwise. Yep. The only difference between rotating clockwise versus counterclockwise is whether you have a positive angle or a negative angle. Positive angle is counterclockwise. If you are not sure which way counterclockwise is, it's like that. Okay. So counterclockwise is positive angle. Clockwise is a negative angle. Okay. So those are the 2 different directions we can rotate on a circle. Counterclockwise, clockwise. In general, what kind of angles do you think we would prefer to work with?
Positive.
Yeah, we can work with positive. That's easier just because arithmetic with positive numbers is easier. Okay. All right, so let me show you a diagram. I think I showed you this last week.
So nasty.
Okay, so if we look at this diagram, it doesn't tell me the coordinate, but it does show me the angle. As I rotate counterclockwise, I get an angle that's positive in degrees or radians. And if I rotate clockwise, then I get an angle that's negative. Okay? If the top number is degrees, the bottom number is radians. Okay. Remember, when we want to convert between degrees and radians, that's the pi over 180 or 180 over pi. Okay? Depends which way you want to convert. If you want to convert from a degree to a radian, it's pi over 180. If you want to go the other way, it's 180 over pi. All right. I would say in this section, most of the time, we're going to go from a radian to a degree because most people can visualize degrees in their head easier than radians. Right? Like if I said a 45-degree angle, most people can kind of like picture how big that would be. So now, let's look at what happens if we go more than one revolution. We could end up right there, okay, 450. So I want you to look right now where that red circle is on the perimeter of the circle, right? That red ball thing. That's at 450 degrees. If you were to write the coordinate for that red circle now, or write the coordinate for it now,
Would it be the same?
it would be exactly the same. So in terms of writing a coordinate, there's no difference between 90 and 450. They are the exact same coordinate. Which one do you think you would want to work with?
90.
We would want to work with the 90. We always want to work with the one that's smaller because it's simpler. Okay. How could I change 450 into 90? There's some arithmetic.
Division.
No, we can't use division. What else could we do? To change 450 into
Make it
90.
into a fraction.
Subtract
and simplify.
by-
We could subtract how much?
360.
Yeah. Okay. If you have an angle that's too big to work with because you've gone around extra times and you want to visualize that angle easier, take that angle and subtract 360 as many times as you need to until you finally get an angle that's small enough for you to work with. Okay? For me, I would say between 0 and 360, that's generally what I try to find. Okay. So if you have an angle that is bigger than 360 and you want to reduce it, keep subtracting 360 until you get the angle small enough for you to work with. But what would happen if you subtract 360 too many times?
Negatives.
Yeah, make-
Right. If you do it too many times, it's going to become negative. So then how do you think you would fix it?
By adding 260.
Right. Okay. So if you have an angle that's bigger than 360, you can make it smaller. If you have an angle that's negative, you can make it bigger by adding 360. Right. So if I asked you to find the coordinate for, say, negative 900, if you didn't know what that was because you've gone around too many times to kind of keep track of it, you could add 360 one time and realize it's the same as negative 540. You could add 360 another time. It's the same as negative 180. And then you could add 360 one more time and realize that it's the same as 180. It's going to be a lot easier to work with angles between 0 and 360 than something like negative 900. Okay? So any question on that idea of adding or subtracting 360? Now, when you do that, it doesn't change the answer to the question. You will still get exactly the same answer. Right. So let me show you an example. Let's take the sine of 10. Okay. I know that's not a multiple of 30 or 45. I'm just showing you something on the calculator. If you add 360 to 10, what do you get?
370.
370. And how does the answer compare for either one?
It's bigger than them, right?
So how do those two answers compare?
Oh, they're the same.
Yeah, they're the same. Right? They're exactly the same. I'm not saying that 10 and 370 are the same number. No, it's That's not what I'm saying. I'm just saying that if you add 360 and you plug it into a trig function, you will get the same answer.
It's a trig function.
Sine, cosine, or tangent. We're going to talk about those in a second.
I don't like trigs.
Here's another one. Cosine of 20. That's what you get. What do you get if you add 360 to 20?
That's 380.
Cosine of 380, and the answer is exactly the same. So if I had to choose which one I could work with to get that answer, I would choose to work with the 20 because it's smaller. How about if I had sine of negative 10? What would that be the same as if it was a positive number?
350.
Yep. If you add 360 to negative 10, you get 350. And if you did 350 and you added another 360, what would you get?
The same number.
You get the same answer. You can keep adding 360 as many times as you want. It will not change the answer because you're at the same coordinate on that circle. That's why. Okay? You have to add a full revolution to get to the same spot. Either add or subtract. All right, so now let's see if we can figure out the coordinates for just the 4 angles that I have labeled on the board. Okay. 0, 90.
How do you have coordinates without a grid?
How do we have coordinates without a grid? Well, we know that this is 1 unit. So I mean, I could make a grid if I wanted to, but we don't really need it.
So would it just be 1, 1?
So this would be 0, 0. That's the origin. What would be this coordinate?
1, 0.
Yeah. That is the coordinate for 0 degrees on a unit circle, and that never changes. Okay, so that's a coordinate you need to know. Okay, 1, 0. How about the coordinate for 90 degrees?
0, 1.
That is 0, 1. The x value is 0, the y value is 1, and that coordinate never changes. That's always the coordinate for 90 degrees. How about for 180?
Negative 1, 0.
Negative 1, 0. And again, it's ones and negative ones because all you're doing is moving 1 unit. It's a unit circle. And then how about if you go down 1 unit?
0, negative 1.
0, negative 1. So those are the 4 coordinates for the quadrantal angles. Quadrantal means they're the angles that are right on the axis.
Quadrantal what?
Quadrantal angles. Yep. Any questions how we got those 4 coordinates? So today we're not going to talk about 30, 45, and 60. Those are the multiples I said we're going to do. We're going to look at those tomorrow.
I got a question. Why are we doing this on a circle?
Because it's circular.
Why on a circle? Well, you'll see what we're really going to end up doing tomorrow is drawing that. So we're going to turn it into a triangle.
So what kind of real world application does this have?
Any application that would utilize trig functions. So one application is, well, I know in programming, if you want to do animation, you can use sines and cosines to do rotations and reflections. So if
Okay.
you want to make something animated, that's how it works. That's one application.
That's pretty cool.
Mhm. So use it when you're doing, I guess, graphic design on a computer when you're programming.
All right.
And there's other stuff too, but that's just what comes to mind quickly. All right, so now let's look at the 6 trig functions. Okay, so somebody earlier said, well, what's a trig function? Well, there's 6 of them. We've studied different functions this year. We've studied like squaring, that's a function. We've done square roots, that's another kind of function. Now we're studying trig functions. Okay, and there are 6 of them. The 3 basic ones that we do are sine, cosine, and tangent. Sine, cosine, and tangent. Each trig function has a 3-letter abbreviation, and that's generally how you're going to see me write it from now on. Sine is abbreviated SIN, cosine, COS, and tangent, T-A-N. Each one of these trig functions is defined as part of a coordinate on the circle. If you want to know the sine of an angle, the first step is you need to figure out the coordinate, and the sine is the y value. If you want to know the cosine of an angle, the first thing you have to do is figure out the coordinate. Guys. And then find the x value. If you want to find the tangent of an angle, you need the y value and the x value, and you divide them. So each trig function is calculated from the coordinate. That's the most important thing in unit circle trig. You have to know a coordinate. If you can't get a coordinate, you can't do unit circle trig. Okay? So those are the first three: sine, cosine, tangent. And on the graphing calculator, you might have seen the three buttons in the middle here: sine, cosine, tangent. That's the three trig functions that we're talking about: sine, cosine, tangent. Does anybody know one of the names of the other three? There is no button for them on the calculator. Doesn't mean we can't do them on there, but
I think we did them in algebra too.
anybody know one of them? Okay, well, the first one is cosecant.
Oh, isn't secant one of them?
Secant is another one. And there's one more. Anybody know the last one on the right side? It's a co-function, meaning it's one of the functions you already have, but it has co in front of it.
Cotangent.
It's cotangent. Yep, good. Again, all of them have a three-letter abbreviation. Most of them use the first three letters, but cosecant does not. How come cosecant doesn't use the first three letters?
Because that's the same as cosine.
Yeah, we've already used COS for cosine, so they just do cosecant. They just use the syllables, CS. And what do you notice about the connection between sine, look at the answer for that one, and cosecant?
It's the reciprocal.
Yeah, it's the reciprocal. Okay? If you take the tangent and you flip it, you get the cotangent. So really, you only have to memorize the three on the left, and then you automatically know the three on the right, because it's just the reciprocal. Yep. And this right here, that is an angle. That's the angle, if I go back to the picture for a second, that's the angle that you would have right there. But that angle is not what's important. What's important is, can you figure that out? That's the point where the terminal side of the angle hits the circle. That's what we have to know to do unit circle trig. Okay, we've got to figure out that coordinate. For today, you're only going to be working with either a coordinate that I give you, or one of these four angles, which hopefully now you know the coordinates for. Okay. Any questions on those 6 trig functions? Okay, not the only way to define them. If you've seen like opposite, adjacent, and hypotenuse, if you remember that from Algebra 2, that's another way to do this. It's actually the same thing, just a different way to look at it. That's the same thing.
So it's kind of just like you flip them?
What's that?
Like for sine and cosine, you just like all of them?
Well, from left to right, you flip
Yeah.
them. Yeah. So like, that's not a fraction, but if you want to think of it, you can always put it over 1. And then if you flip it, you get the secant. Okay, so you do have to remember, when you flip sine, you get cosecant. When you flip cosine, you get secant. And when you flip tangent, you get cotangent. What do we call those 4 angles again? I gave you guys the name earlier. 0, 90, 180, 270.
Angle circular angles. Something like that.
They begin with a Q.
Quadra circle.
Quadrant.
Quadrantal angles.
And
Close enough.
So yeah, 0, 90, 180, and 270, these are called the quadrantal angles because they're on an axis.
Quadrant.
And the axis gives you 4 quadrants when you draw them.
Why do they have so many easy names?
I don't know.
Can we just give them all like
Wait, leave that there
names?
for a second, please.
Yep, I can leave that. All right, so how do you do unit circle trig? There's 2 steps. Step 1, what's the most important thing I keep saying you need when you do unit circle trig?
Angles.
No,
The
not the
coordinate.
angle. You need the coordinate. So, in order to get a coordinate, you have one of 2 options. One, either I give you the coordinate, and then if I give you the coordinate, you're all set. Or, if I don't give you the coordinate, you have to figure it out yourself. Okay, how do you figure it out? You're going to use that diagram that I gave you with 0, 90, 180, and 270. Well, what if it's not one of those 4? That's tomorrow. Okay, today, it will be. So it's either going to definitely be one of those 4 angles, or it's going to be something I give you. Okay, so that's step 1, find the coordinate. Step 2 is to take your coordinate, use the definitions on the left side, and plug your coordinate into those definitions. Okay, which one? We're going to do all 6. Okay, so once you get a coordinate, we'll fill it into all 6 formulas and see what we get. Remember, there's a couple things we got to make sure we do when we write an answer for unit circle trig. One, we cannot leave a square root in the bottom of a fraction. Okay, so if you don't remember how to fix that, I will show you. The other thing is you always want to reduce your fractions. You wouldn't want to leave an answer like this.
I think we should work with only whole numbers.
Yeah, there's going to be some square roots in here. These numbers are all nice. We saw that the coordinates for 0, 90, 180, and 270, they're all nice numbers. 1s, 0s, negative 1s. But when we talk about the 30 and the 45, we're going to get some square roots.
But you said that's tomorrow, right?
That's tomorrow. Yep. So step 1, find the coordinate, or I'll give it to you. Step 2, plug the coordinate into those 6 trig functions. On the test, I would only ask you for one of these 6 functions per problem. Okay. I wouldn't ask you to do all 6 in the same problem.
Is that like a possibility for later though?
No.
Okay.
No. It'll be one trig function per problem. But between all the problems on the test, I'll hit all those different functions. Yeah. All right, so let's try this one. So P, that's just a letter that stands for point. P is just my point. I'm giving you the coordinate -1/2, comma, √3/2. Okay, first question. Does that look like the coordinate for
No.
0, 90, 180, or 270? Any of them?
No.
No, it's not. It's a different coordinate. By Wednesday, you'll know what it's the coordinate for. But that's not important. It doesn't matter what angle is being represented by that location. We don't care about the angle. All we care about is where the angle is. If you were to draw the angle on a circle, it would look something like this. You'd have your initial side right here. You'd have your terminal side over here. That's the angle that they're talking about. I don't know what it is, don't care what it is. I care about this. And that's -1/2, comma, √3/2. You do not have to know how they figured that out. They're giving that to you. Okay. Now we're going to plug those into our 6 trig functions. The -1/2 is which letter in your coordinate?
X.
It's your x, √3/2.
Y.
It's your y. And now let's fill them in. Okay. 2 pages ago, what did we say, Alejandro? What's the definition of sine?
Is it Y?
Did you write it down? I'll write it down. Yeah. What's the definition of sine?
Equals Y.
Sine equals y. Yep. What's your y value in this case?
Square root 3/2.
Yep. That's how you write your answer. Sine and cosine are the easiest two because you don't have to flip anything, you don't have to divide anything. It's just part of the coordinate. What's our definition for cosine?
X.
X. What's the x value in this coordinate?
Negative 1/2.
-1/2. What's our definition for tangent?
Y over X.
It's y over x. Well, we just did y right there. We just did x right below it. So just imagine putting a division line right there. And now you're going to take y and divide by x.
So is that like multiplying by -2?
So, yep, we can, when you divide by a fraction, you can flip and multiply. Or, a shortcut, if you notice you have a -2 in both denominators, if you were to flip that bottom one and multiply, what would happen to the 2's?
Multiply to 4.
I'm confused.
Like if you took,
They would cancel out.
and you flipped the bottom one and multiplied, you'd have that.
You just get like a -1.
Right, the 2's would cancel out, right? Because you have a 2 in the top and a 2 in the bottom. If you flip and multiply. Remember, keep, change, flip. I know some people learn it that way. You keep the top the same, change it to multiplication, and flip the bottom. That's how you divide by a fraction. So these 2's just cancel out. So I'm not even going to worry about the 2's. If the 2's cancel, what's left in the top?
Square root of 3.
Square root of 3. And if the 2's cancel here, what's left in the whole bottom?
-1.
Just the -1. And you can leave your answer like that, or if you reduce it completely, it's negative square root of 3. Either one is okay. That's how you find the sine, the cosine, and the tangent. This one, CSC, how do you say that one? Cosecant. And if you know this answer,
Flip it around.
what do you do to it to get that answer?
Flip it.
Yeah, just take and flip it. If you flip it, 2 goes to the top, square root of 3 goes to the bottom. Now, what did I say we have to make sure of when we write our final answer?
So, again, it's square root
Right, well, we can't get rid of it, but we can't leave it,
on the bottom.
we can't leave it on the bottom. Only thing you can multiply a fraction by that doesn't change it is what number? 1. 1 just means same thing in the top, same thing in the bottom. As long as you do the same thing in both, you will not change the actual value of the fraction, you'll just change how it looks. To fix a square root in the bottom, you multiply the top and the bottom by the same thing, the square root. If you multiply straight across the top, what would you get?
2 square roots of 3.
All you get is 2 square roots of 3. And when you multiply in the bottom, the square root of 3 times the square root of 3, you can put that together. That's the square root of 9, which is how much? 3. So effectively what happens when you do that is the square root symbol just goes away. And that is how you find the cosecant. Not every fraction is going to flip and have a square root in the bottom. What do you get if you flip -1/2? -2. So that one's easy. Flip it, there's no square root in the bottom. And this last one, what's the name of COT? Cotangent. And which trig function do you flip to get cotangent? Yep. If you flip the tangent, can you tell me the first step of what you would have?
You have to multiply by the square root of 3 on both the top and the bottom.
Okay, so what would you have first before you do that?
-1.
-1
Over 3 square root.
over square root of 3. Now we're going to do what Natalie just said, multiply top and bottom by square root of 3. And what does that give me in the top?
-1 square root of 3.
-1 square root of 3. You can just put negative square root of 3, that's okay. And in the bottom?
3.
3. Those are the 6 trig functions of that angle which is represented by that location. Okay, so I don't even know what that angle is. I know where it is. That's the most important thing for unit circle trig. Where is the angle, not what. Okay. All right. Any question on that one? All right, let's try this one. So it says find the 6 trig functions of, and now we have an angle that's represented by that coordinate. Okay, first question, does that look like the coordinate for a 0, a 90, a 180, or a 270? Does it look like any of them? No, it's not. It is the coordinate for something else.
That we don't know.
We don't know. Okay, we don't know what it is the coordinate for, but that's not important. We don't care what angle this represents. I don't care about what the angle is. I care about where it is. And that's where it is. That's where it would hit the edge of the circle. Okay, so let's start with sine. Brett, what's my formula for sine? Okay, did you write it down? No. Kayla, can you help him out? What's the formula for sine? Sine is y. What's my y value in this case, Brett?
Be square root of 2 over 2.
Right. It's the second one. Even though they're the same, if you switch them this time, you get lucky because they're the same. But you should know y is the second one. Square root of 2 over 2. Okay. How about cosine? What's my formula for that one?
Same thing.
Yep, it's the x, which in this case it just happens to be the same. Usually they're not the same. Okay. What's my formula for tangent?
Is it 1?
Yeah, what's the formula though?
X over
Square
1.
root of 2 over 2 divided by square root of 2 over 2.
And what's the formula you use to do that?
X over 1.
That's cotangent.
Y over x.
Y divided by x. That's the formula. So just imagine dividing them. But look at y and x, they're the same number. When you divide two things that are the same, you get 1. Now, just because this one's easy to flip, what do you get when you flip 1?
1.
1. So there's two numbers you can flip and they stay the same. 1 and -1. Okay, so now we've got 4 out of 6. How am I going to get the cosecant?
Flip around
Flip what?
the sine.
Flip the sign. What's my first step when I flip the sign? You don't have to fix it, just tell me what you get.
2 over the square root of 2.
2 over the square root of 2.
Okay.
Okay.
Yeah.
And now, how are we going to fix that so we don't have the square root on the bottom?
Multiply square root of 2, top and bottom.
Yep, multiply the top and the bottom by the square root. Okay. Go straight across. What do you get in the top? What's in the top? If we go straight across?
2 square roots of
2 square roots of 2. And what about in the bottom?
2.
Yeah, square root of 2 times the square root of 2, that's the square root of 4, which is 2. But then, what do you have on the outside of the square root that's the same?
2.
A 2. Because you have the same thing in the top and the bottom, you can cancel that. And that is what you end up with. Okay, we're going to be flipping root 2 over 2 a lot. So if you remember when you flip root 2 over 2 that you get root 2, it saves you some time. Because that's a real common one. How about the secant?
It's going to be the same.
Yeah. It's going to be the same thing because the sine and the cosine are the same thing. So there's no reason to do all the work again. And that's the 6 trig functions of this angle, which is represented by that location on the circle. Anybody know what angle that would be? You've gone right and up exactly the same amount.
90.
No, 90 is, we've got that coordinate. That's 0, 1.
would it be 180?
No, we've got that one too. That's negative 1, 0. That-
Zero?
That's a 45, yeah. That's the coordinate for a 45 degrees. When you go right and up, exactly the same amount. You get a 45. For today, you don't have to know that that's the coordinate for 45 degrees. That's not important. What's important is what the coordinate is, not what that angle is right there. Okay. Let's look at this one. What is different about this question?
It gives us the angle.
It gives us the angle. Remember, that's what the angle is. That's not what's important. What is it that we need?
Coordinate.
We need the coordinate. We have to figure out where that angle is, not what it is. Okay. So if you're not sure where 90 is, draw a diagram. Where's 90 on that circle? It's the one at the top. What's the coordinate at the top of the circle?
0, 1.
There you go. 0, 1. Now we have the coordinate. We can fill it in. We can do all 6 trig functions. Okay. Start with sine. Sine is which letter?
Y.
Y. And what's the y value?
1.
1. Okay. Cosine is which letter?
X.
And the x value in this problem? 0. And my formula for tangent is what?
Y over X.
Y over x. So it's y over x. But what is 1 divided by 0?
0.
No.
1.
No.
0.
Divided by 0.
1 divided by 0 is what?
0.
Not 0. Undefined. Yeah, you can't divide by 0. So 1 divided by 0 is undefined.
So we can
Remember,
just put 1 over 0.
I'm going to ask you to simplify it because I need to know if you know the difference between this and that, which we're going to talk about in a second. Yeah. So when you have a number and you divide by 0, a number divided by 0 spells
25.
no. And oh, okay. Number divided by 0, no. No means you can't do it. All right. Cosecant. What's the name of the function that we flip? Sine. And if you flip the 1, you get stays the same. All right. Now we have 0. It's not a fraction. How can you make it a fraction?
Put it.
Yeah, if you want to put a 1 under it, you could. What do you get if you take 0 over 1
Undefined.
and you flip it? You get undefined. So if you flip 0, you get undefined. What if you flip undefined?
Then you get 1.
You get what?
0 over 1.
0 over 1, which is?
9.
0.
No, these are different. 1 over 0 and 0 over 1 are not the same. So it's not, I heard someone say undefined. It's not undefined. What? Somebody else say
Is it
something?
1?
0.
No.
Is it 0?
The only way you can get 1 is if you divide like 2 things that are the same.
Defined.
These aren't the same.
0?
It is 0. Yeah. So when you flip 0, you get undefined. When you flip undefined, you get 0. So 0 in the top of a fraction, that's fine. If you've got $0 and you split it up between 10 people, everybody gets 0. 0 divided by 10 is 0. But you can't divide by 0. That's different. All right, let's try this one.
Oh.
This time, they only want sine, cosine, and tangent. Okay. What have they given me this time to work with?
3 pi.
3 pi. What is this?
Gradient,
It's radians, and it represents.
270.
Well, first, why would I use radians? Like, what does it measure?
Degrees. No. If you convert it, it measures the.
Is it the length of a side?
In between.
Yes.
The length of the arc.
No.
Yeah, it's like the length of the arc, and if you think of it in terms of a triangle.
That's what I was saying.
Yeah, in a long way.
No, you weren't.
No,
The
I
side
said
is
this.
called an arc.
No, it measures this part.
The arc.
So it's the, if you had to say it in one word, it's like the arc or the,
Measures the arc.
That's not one word.
Sector.
That's the whole piece.
Sigma.
what about, so I heard somebody say like a sector, what about the sector though?
The arc. Sector arc.
Like sigma.
Not really the arc length, no.
The arc radius.
Think about what this would measure on a circle.
That a radian.
The amount of what?
3 radians. 3 pi radians.
Degrees.
No. It measures
A distance of an arc.
its amount of rotation, right?
Oh.
It's an amount of rotation. How do you measure, what is a rotation? It's measured
A
by,
revolution.
no. How would you measure, if I wanted to describe how much I'm rotating around a circle, I would have to tell you,
Speed.
The time.
no?
The length.
I don't think we're gonna get it, Chief.
Something.
Well, this is radians, right?
Yeah, radians.
You only use radians to measure really
When it's
one
being
thing in
placed.
trig. You can use degrees to measure this thing too. Those are different, but they
Is it
measure the
also
same
length of
thing.
the arc?
What do degrees and radians both measure?
How far it rotates.
Distance.
Not at the distance, no.
No, because it's in the same speed, doesn't it? How fast it's going around?
Is it the angle?
No, it's the angle, yes.
The angle of
Well,
what
you're so
is-
smart.
The angle that you draw, like if you put your angle right here,
So it's the measure of the angle?
it's the
not-
measure of that angle right there. That's not to scale with this one, but that's what it measures. Radians and degrees measure the size of an angle.
I feel like you never said that before in your entire teaching career.
Dude, he literally taught us this last week.
Yeah,
You
isn't
couldn't
it?
say something sooner?
Sure.
All right, so now they gave us an angle. What is it that we need to do unit circle trig?
The coordinate.
You need the coordinate. So now you have to figure out how to get the coordinate for 3 pi. What would make 3 pi easier to work with?
It was an
Simplifying
angle.
it.
The degree.
Right, it is an angle. 3 pi is an angle, but if we changed it to degrees, it would be easier to work with.
Yes.
Wyatt, how do we change that to degrees?
You flip 3 pi over.
Don't flip anything.
Well, no, 3 pi over 1 and then 180 over pi.
So you could put 3 pi over 1, that's good.
And then 180 over 1, or 1 over 180 over pi, I mean.
Yep, multiply by 180, divide by pi.
I bet you did not expect me
Okay.
to answer that correctly.
I'm happy you did. What cancels out there?
Pi's.
Pi's. And what's, put our 0 there, what's 3 times 18?
18, why 18?
Well-
That's the first 2 digits.
560.
I could do 3 times 180, but 3 times 18 is easier for me to
How is
think
it
of.
the same
24,
though?
5 reaches.
Because you got a zero.
540.
Just do 3 times 18 and put a 0.
540.
5, yeah.
Oh, it's the same?
Yeah.
That's zero.
3 times 18 is 54.
I never learned that.
So you put a 0 and you get 5. Okay, so now we've got an angle that's 540 degrees. That's
Wow.
a little bit easier to work with.
30, 60.
It's a little bit easier to work with, but it's still too big. So, because we want to work with
Subtract
angles,
360.
yeah, we want to subtract 360.
It's just 180, dude.
I'm good.
So take 540
That's 180.
minus 360,
Oh my god, that's 180.
and we're working with an angle that is 180.
Oh my god.
Now,
My goal was to get my.
Negative 10.
That hopefully will help.
okay, because we know it's 180, what's our coordinate?
Negative 10.
Yep. So now we know the coordinate, negative 10. What is the sine of 3 pi?
0.
Zero.
Sine is the y value. What's the cosine of 3 pi?
Negative 1.
Negative 1. That's your x value. And what is the tangent of 3
Zero.
pi? What is it?
Zero.
Yep.
Huzzah, we made it.
Any question on how we got the 3 trig functions for 3 pi's? Okay. Why? Is that yours, Jack?
Yes.
Yeah.
Would you like me to put it?
Put it away for me? Yeah, thank you.
Of course. Very distracting.
Okay. Let's try this one. Find the 6. They want all 6 trig functions of 11 pi over 2.
So we need to get the simple
Okay, Wyatt and Caleb, be quiet. I can't.
Wait, that's
use
the angle?
too
He's
many
asking
people
for the
talking.
final answer. for the
Okay.
last one.
I can put it back up in a second. So what did they give me here?
The angle.
They gave me the angle. That's not what I need. I need the
Coordinate.
coordinate. So when I'm done,
To read. Yeah, read.
that's what I need to figure out.
Okay.
Okay? However we can get that coordinate. So what did you suggest?
Turn the radians into
It's already in
degrees.
radians.
Okay, we can turn radians into degrees. How do we do that?
Just turn it into radians.
Coordinates.
What?
Like, why do we need the 180 pi?
That's what we've been talking about.
Because all the formulas are based off the x and the y value.
No, I know, but.
The definitions of these are using the
What do we ask-
coordinates.
what do we ask each other? What's the answer?
So
We're
then
trying to figure it out.
we're going to get 6 answers. You need all the
What's
def.
6 though?
Because we're trying to
I just don't
find
understand why we're
X
trying
or
to find,
6.
like, what's the reason?
You need the definitions again?
It says
No,
find the
like,
6
why?
trig
That's
functions.
the whole
You
problem.
do.
Look at the
That's-
thing, it says find 6 trig functions.
Because that's what we're studying. We're finding the 6 trig functions of an angle.
I was just trying to find, like, what you use this for.
We talked about that a little
It can make
Will
it
ask me that.
rotate and move.
Code.
bit. And I can tell you some other stuff after too you can use it for.
Brett, we definitely need.
I can give you some
Okay.
after-school tutoring if you want.
Guys, focus up.
So if we're going to change that to degrees, what's the first step?
Multiply by 180 or by.
Thank you.
Okay.
Good job, William. I'm proud of you.
Thanks, Caleb. Your opinion really matters.
We don't.
So Caleb, what's our next step?
The next step would be to cancel out the pies.
Aiden, please be quiet. The next step, yeah, the pi cancels.
Yes.
Okay. What else can we do?
Impressive. 11 times 180.
We could, but we can reduce first.
11 times 8.
Divide by
One,
2.
one and 90, dude.
Hold
180
on, one
divided by
one
2.
person. Yeah.
180 divided by 2.
Yeah, what's 180 divided by 2?
90.
90.
6
90.
Dude, they're all numbers. It's all the same.
And then 11 times, can you do 11 times 9 and add a 0?
Yeah.
It appears.
How much is that?
I don't know.
990.
Oh, not.
What's 9 times 11?
Okay. So we got 990. So now we have an angle. It's in degrees. It's still kind of a hard angle to work with because it's what?
Over 360.
It's over 360.
Subtract.
What are we going to subtract from?
360 from 990.
Okay, and I get that.
Do it
Again.
again.
Right. It's still bigger than 360. So we're going to
So we
keep
subtract.
going.
Subtract.
270.
Wait, we can't subtract more?
No, because.
Well, if you subtract another 360, it's going to go negative. Yeah. So now think about where's 270?
0, negative
You're
1.
in the 4th quadrant.
Somewhere down
Zero.
there.
No, it's not in a quadrant.
It's the
Well,
bottom.
in the quadrant of the circle you draw.
It's the bottom. It's 0, negative 1.
It's on the axis. It's
Oh.
between the two quadrants.
Yeah.
What's the coordinate?
Wow, you're.
So it's 0, negative 1.
So the coordinate is 0, negative 1. Now we can find our trig functions.
Huzzah.
What?
Cosine would be -1.
Sine would be negative 1.
Cosine 0.
Yep. Cosine is
How good
0.
it is.
How about the tangent,
That would be -1 over 0.
which is
Undefined.
undefined?
Undefined.
Yep. Again, make sure on the test if you put 1 over 0, I'll give you half credit because you knew the formula, but you need to write undefined.
Will it let us type that?
Yep. Yep. What about the cosecant?
Is it +1?
0 over 1, negative 1.
What are you flipping?
Oh, wait. It would be 1.
You're flipping negative
It's
1.
negative
So it would just be.
It would be 1.
1. Negative 1.
If you flip negative 1 over 1,
It's
You
negative
get
1.
1.
You get 1
Negative.
with, where's the other negative on below?
when you flip that, you get that. What's that?
Negative 1.
Negative 1.
Oh.
Dude, it's sad when I'm getting these right and you're not.
We'll see on the test, Will.
You probably do.
So when you flip 1, it stays the same. When you flip negative 1, it stays the same. Those are the only two that don't change. What about the secant?
Undefined.
Undefined.
That's undefined because we're flipping 0. Okay, think of it like that. And what about the cotangent?
0.
That's 0. When you flip 0, you get undefined. When you flip undefined, you get 0. Okay. All right, so any questions on finding the trig functions if I give you a coordinate like this one? Or I have you find the coordinate like one of those.
Have we made you proud as a class yet?
We're getting there.
Are you excited for the final?
The final? Yeah, sure.
Are we
Excited
better than
for
your
the final?
honors?
Mr. Hager,
Are we better than your
Hold on,
honors?
guys. Yes.
so when you get the 180 degrees, how do you know the coordinate?
So the coordinate for those, that comes from this diagram we had at the beginning.
Right, but how do you like know which is each?
Because it's 1 unit in each direction, no matter which way you travel. So this is 1 unit right, which means you've traveled 1 unit right, no units up and
It's
down.
like a cube.
This is 1 unit up, this is 1 unit left, and that's 1 unit down. Because it's a unit circle. If we didn't know it was a unit circle, we wouldn't know how far we traveled.
Okay.
Okay. Any other questions on those 4 angles? Okay. So tomorrow, we're going to look at the 45, the 30, and the 60. So we're going to see how do we get the coordinates for those, and you've already been working with the coordinates for those. The only thing we don't know yet is how do you figure out that coordinate if they don't give it to you.
Yeah.
So tomorrow I'll show you that one, and I'll show you one like that, but it won't have a negative in it tomorrow.
Can you go back to the circle real quick?
Yep. Okay, and then once we know how to do the 30, the 45, and the 60 in quadrant 1, it's going to be exactly the same thing in the other quadrants. Just you might see a negative in front of the number, but it's always going to be the same numbers. And then on Wednesday, if we get one that's not a multiple of 30 or 45, that's where we plug it in on the calculator because we
I thought you
can't.
said we can't do it if it's not.
Well, we can't do it on the
Right now.
unit circle, but we can still type it in on the
I
calculator.
think we're just gonna do it wrong. And then,
Yeah.
like, that's okay. Done.
Nope, we'll be able to do it. We're just going to do it on the calculator
Why don't
instead.
we just do it all on the calculator?
Because the calculator's not going to give us the answer we need as a fraction. For example, if you do this,
Yeah, but why do we need it as a fraction?
it's going to say that.
But isn't it the same thing?
I'm going to ask you for an exact answer on the
That's
test.
exact.
No, that's a decimal.
Wouldn't that make
Aren't
sense?
exact?
Yeah, I never got that.
No, these
I'm
ones are
guessing
gonna
it's
keep,
more exact
these
than
are gonna
fraction.
keep going on.
No, because it doesn't stop at 2. It just keeps going forever. And if it just keeps going forever and there's no pattern to it, you need to write it like this. This is the only way to write that number as an exact answer. It's the square root of 2 divided by 2. That's exact. There's no rounding there. If you write 0.707, 106, 7812, you rounded it to 8 decimal places or whatever. Okay. So we're gonna talk about how you write it exact. So I'll show you that tomorrow. For today, you don't have to worry about it because all the numbers are 1s, 0s, and -1s if I don't give you the coordinate.
So when they're not multiples of 35 or 30 or 45?
That's a calculator thing.
We don't need to be exact?
No, you can't be exact when we do it that way. No. No, when we're dealing with numbers that are like, let's say I asked you to find the sine of 17. I don't know of any exact way to write that answer.
Okay.
There might be, but that's not something that we look at. Okay, so 30s and 45s are the ones we do exact. Yeah.
Awesome sauce.
So that's the homework for tonight, 11 to 27 odd, and number 22, that's the only even.
What unit is 2.2?
This is 2.2 part 1. Yep. Okay, and you've got about 12 or 13 minutes left.
Are you best friends?
What's that?
Are we best friends?
I think we're more a student teacher.
Oh.
Yeah.
What do we do?